So thank you for coming in. My name is Markus Kraft. I'm product manager from SUSE. I'm working based out of the Nuremberg office, and I'm focusing mainly on SUSE Enterprise for now Z Systems. We're doing a little switch. We're following in IBM's rebranding of the platform for Z Systems and LinuxONE. And with me is...
Yeah, my name is Steffen Toss. I'm from IBM Böblingen, like a toothbrush. I'm the offering manager for Linux on C, KVM, CVM, and also Wave. Not really working. I don't know.
This works.
Okay,
right.
I have to keep it very close.
Yeah. So we're doing this presentation together. We built a deck, and we might have at some point need to do a good transition. Anyways, the session is supposed to be that you ask questions, so we're happy to answer that, and we will step you through a little bit of history, customer scenarios, and why the platform is different and what's coming up next on that platform. Okay, so the agenda, why customers are considering LinuxONE, or why should you consider run Linux on a mainframe Z system or LinuxONE system. We will have some success stories, share also information about our partnership over the years, meanwhile 15 years, a glance at the product portfolio, a technology outlook from both sides, and yeah, where can you start if you need to start? So quick question, who is already running Linux on a mainframe? That's good. A little bit. Who's planning, or who's just interested to know more, to learn more about it? Well, that's quite a lot of people. Do we have a hardware background, or is it just general interest to understand the platform better? Or what is your motivation to come? So you want to have an introduction, what it's all about? Yeah? Okay. Mm-hmm.
To know what's the news there.
Okay, okay, good. So from as a start, we thought, what are the current, or what are the challenges or the needs of people in the market we see? These are generic ones that could be also ones where customers already have a mainframe. Looking from a mainframe perspective, they are not alone. So customers have typically an environment where they have multiple different hardware technologies available. So the question is, what would be preferred workloads to run on a mainframe, on a LinuxONE system? Which systems would be better suited? But they need also coexist with, not with the traditional workloads, but the emerging workloads regarding distributed systems and cloud. One thing probably everybody faces is that the technology is creating new possibilities, how to deploy systems, how to manage them, and that also introduces a ever-growing complexity. So what we see is people are aiming to make things much simpler, but the variety is also growing, and thus if you want to manage those systems or run the IT infrastructure efficiently, you need to focus where, or you need tools where you can actually concentrate and hide that complexity in other blocks. There are traditional workloads, but plus new emerging ones like analytics, making use of the data which is available, which is coming in. Big data, DevOps are the topics there. Developing new applications. Always a cost pressure there. What is the best way to achieve your line of business goals and deliver business value? And another point which is also important in this area, how do we attract new talent to that platform? There are, given the nature of devices, probably everybody has a smartphone today. Most of us have a personal computer or laptop, but the people who have ever seen or heard the term mainframe is kind of shrinking, unless they go to a specific university which is teaching classes around that, right? So how do we get new talent, young people to the platform? Because, and that's a good transition, lots of the workloads, the transactional workloads and systems which deal with large data and records are mainframe based, system of records. Should we do the positioning?
I have my own toothbrush, but the clicker. So, okay, how does IBM, together with SUSE, address what Markus just mentioned, right? So we have two brands. One is addressing more the traditional mainframe customers, IBM C systems, where you really run your COS together with CVM. You can also run Linux on the same box, so it's more for the traditional customers who know the mainframe technology and who are aware about the platform. Last year, we announced the LinuxONE, which is from a technology point of view really kind of same, but we want to have a different discussion with customers. Right? We don't want to go into some of the customer shops and talk about here's mainframe technology, because this alone sometimes kicks you out of the discussion, right? Because they say, oh, we don't want to have a mainframe, we don't want to understand it, it's old technology, we don't want to hear about it, which is most of us know it's not true, right? So IBM invested over the years, renewed the platform. You can run Linux on the platform since 15 years. So it's really kind of starting the discussion differently with customers. So we mix up a little bit during the presentation. We talk about LinuxONE or C systems. Just as an overview for you, it is really the same technology, but we use the different brands for different customer set. If you have a customer, let's say as Balder, who's very, then they know mainframes since a long time, right? We can have a C systems discussion because they know the values, they know the advantage of the mainframe. But if you go to new customers, to really open the door, we talk about LinuxONE as a platform. Okay, and for LinuxONE, we have two systems. It's the Emperor, the biggest system, and also a kind of a low-end system which is called Rockhopper. This is the one you see in the booth. That's the glass model. I would really recommend to go there, look at it. They explain to you into detail. But I will also explain some of the technologies and some of the architectures today. First of all, who is using Linux on IBM C today? And as I said, LinuxONE is in the market since 1 year. We get very slow traction into this, but more and more customers also going this. It is mainly, and sorry, you cannot really read this, it's the banking sector, government sector, and insurance sector. So it's no surprise that these industries are using a high, sophisticated, reliable system because their business is based on data. So any outage they can definitely not afford. So they are willing to pay much more also for taking out the risk of their environment. Right? So this is kind of. Then we have, as I said, insurance, computer services, and we have installation sizes from very small, just 2 IFL, and IFL as a CPU, integrated facility of Linux. Think about it as a CPU. And we have also very large installations with customers with up to 1,000 IFLs running just with Linux. So some of the biggest mainframe installations in the world are Linux-only installation today.
Can you mention if these customers are only running Linux or are they running in a mixed environment?
Some of them only run Linux only, but the majority runs Linux together with COS on the same platform, which is actually the beauty. You have your COS environment with DB2 and your data, and you can run on the same system in a different logical partition, a Linux environment. There's less, where you can bring in new workload, like being at a web server, being in analytics software, and so on. So both way.
Accessing and interfacing with that data.
Yes.
So.
This shows a little bit the evolution of our mainframes, but from a different angle. So mainly you see they're getting more CPUs and they're getting more power. This chart really looks at capacity per kilowatt. Right? We all know these systems getting more powerful, clock speeds going up to 5.5 gigahertz. But what it shows here over the generations, starting with G2, G3, up to C13, you get much more MIPS per kilowatt. So this is also a very important factor for customers today because each system requires floor space and also power consumption, right? And we try to keep this power consumption stable and increasing the compute power in parallel. So C systems is very effective by providing a lot of compute power per kilowatt. Quite interesting, and the improvements since a long time is about 55 times. If you look at the last generations, if you compare C13, which is the current model, to a EC12, for a given amount of compute power, there had been 80,000 MIPS. The same system with the same, the newer system with the same kilowatt provides you 112,000 MIPS. So it's really an advantage also for customers, not just the pure compute power, also the savings in electricity.
Yeah, let me also add one word. So this is trying to keep the power consumption envelope at a good level while still delivering more performance or more capacity to the marketplace. So it is trying to squeeze as much potential capacity into one box. And for those who are not familiar with the mainframe, don't just think of a just big server. It's more a data center which you have in one box, right? It's kind of complex, all the things you find when you want to do cabling and connecting servers, distributed servers in an environment. You can do so in that machine by using virtualization technologies.
Yeah.
And
we show that later also.
Yes, just
so it's not just adding pure compute power, also efficiency. This is the goal when we're moving forward and bringing out new machines. Okay, so the system is really designed in a way that you can run a lot of workload on the same box, as Markus mentioned. And here it's really important if you have workload with different requirements. So you have a high priority workload, for instance, which is here in blue. So this is from our competitive office. They ran 10 virtual machines with a high priority workload, being your production environment or your web server or whatever. And in parallel, they run 14 virtual machines, which has a low priority workload. Think about a development system, an internal server, which really is not so important. You want to make sure that your high priority workload gets all the resources, right? And if you look at the Intel space, and we did this here the same, so the low priority workload is this color code, and they put on the low priority on top of the high priority, you see that on an Intel environment with a virtualization technology there, this high priority workload gets impacted. This is also the reason why some of these Intel servers only are run with a very low utilization, because this is the effect you get if you put more workload on. We have to be fair. x86 also improving into this direction. They look at our technology, they're getting better in this direction there. But on C, you see very nicely the low priority workload fits in the gaps of the high priority workload, and you can run this workload together on a system.
Yeah, so with regards to the benchmark and how it was carried out, it's not a micro benchmark. It's using multiple systems, so 10 VMs running in parallel, heavy workload, and then 14 ones with low weight. So the system only has to consume all that or manage these different type of virtual machines that the workloads within it needs to balance it out. And for that, with regards to the hardware system design, there's technology in the mainframe which allows for better scalability regarding the physical resources used and exploited.
And the system was the system was started 60 years ago when resources really was a problem, right? Memory was a problem. So and IBM really designed 60 years ago because of the resources. And they keep going with that. And now we really have the benefit of running large environments on these resources because the technology is in there. Right? It's the hardware, it's the operating system, it's the hypervisor, up the full stack. We try, and these components working together. So SUSE Linux Enterprise Server is talking to our hypervisors like KVM or CVM, and this again talks to the hardware to really balance the resources through the full stack, which is really.
We'll have some examples.
Yes. Okay. This is a nice chart. Who has not seen this chart before? So it's used many, many times. But it shows very nicely the evolution of our system. So we have C13, which is our current system, or Rockhopper, or Emperor. We had these systems before. And you see, it's actually not really nice to read. This is how the number of processors evolved from C9, from 54-way to 64, 80, 101. And you see there is quite some improvement. So each generation gets more CPUs and compute power to use. What's more interesting here, years before, memory was not really an issue, right? You got from 512 gig to 1.5 gig per machine to 3 terabyte. But here it made a big jump. Because in the last years, with these in-memory databases and the sheer amount of virtual machines required from our customers, we really had to put much more memory in here. And you can run much more virtual machines on it. And I think this is also the trend we go forward. Follow-on machines will still see an enhancement here with getting more compute power and cores into the system. But I'm expecting more enhancements here. So I'm expecting further machines will have 20, 30, 40 terabyte of memory available, which can be used from virtual machines. It's kind of an industry trend already, right?
So I like this slide very much because you can very easily explain why this platform is well suited for mass virtualization consolidation. So if each virtual machine needs a way to process the instructions, it needs to do some I/O, which is on the upper part. It needs some memory where the workload resides, and then you have, depending on the processor, you have a more or less powerful processor. But if you think that a virtual system is a little tile which you place into the system, any means you take to expand the overall envelope will create the opportunity to put more virtual systems in that box, right? Okay.
Okay, just very quickly about that, you have spare capacity. So even if you buy a mainframe, little bit unusual concept is you get all the CPUs, but you pay only for the ones you can only use the ones you paid for. But this allows you to enable some of the CPUs on demand. So if you let's say if your year-end processing and you need more compute power, you can use these built-in but unused capacity temporarily for a lower price for your year-end processing, and then you give it back. It's also a very nice feature and can be used from all operating systems. And you can turn them on and off without any rebooting and bringing down the systems.
Yeah. And that you really take out the configuration. I mean, the latch is being configured in the processor, and that state is being transferred to another one and restarted at the point where the operating system doesn't see that. So it's transparent failover within the box.
Yeah. So your workload will not see it. And then IBM support shows up and is really exchanging some of the, it was books, now it's nodes, and they can exchange these nodes during flight without bringing down the workload. If you have the smallest machine, to be honest, with only one node, you don't have spare processors. So it's just for the bigger systems.
The concept is also very valuable if you need to have disaster recovery on multiple sites. So you size the system on one side to have to cope with your workloads, and probably you will have some white space left, processors which are not configured, and then a second one on the other side, and they can work in parallel. But if one side fails down, you could use these capacity on demand processors to ramp up the capacity on the other side. The same is true for memory. You can expand on memory if it's available in the system, and then you have a failover, and you have the capacity you had on both sides being then available on two sides, and then go for the recovery action on the failing side, and then fall back down. So lots of customers are using that.
And a lot of customers also practice this. I think maybe in Beldo you do it. They practice also failovers in case of emergencies and really test if these things are happen, right? Not all customers do it, but. So this just quick comparison about it. The processor technology, Intel has 18 core with 2.3 gigahertz. We have 8 core with 5 gigahertz. And we also have technology like SIMD, out of order processing, transactional memory, and SMT since the last generation is also available. So quite comparable, but a different architecture. Okay, I think this is spare code. Yeah, this is just an example about a Linux Rockhopper, the small system, where we have 20 cores. The smaller systems have a little bit reduced clock speed and a little bit less memory, but you can also upgrade. So if you start with Rockhopper system and you figure out, okay, I grow against the capacity of that Rockhopper system, you can upgrade also to Emperor, to a bigger system. We have to speed up a little bit. This is some details about the bigger one. This is the what you mentioned, the spare processors, right? This is I have unused,
I was a bit ahead.
Unused processors. Now we're coming to the virtualization technology on that system. So what you really have is you have the hardware with logical partitions on top of it. So you cannot run only one operating system directly on the hardware. There is already a virtualization layer on top. For the big machines, it's 80 LBARs. For the small machines, I think it's 20 LBARs, logical partitions. So in each of these logical partitions, you can run Linux on top, or you can run a hypervisor being CVM or being KVM. And then on top of this hypervisor, again, you can run virtual machines. So you have two virtualization layers. Actually, the history is CVM was there before, and they took some of the CVM code down into the hardware. So the code here in the logical partition is kind of I think, deviated a lot now, but in the beginning, they really used some virtualization from CVM down into the hardware. So really have a big flexibility what you want. So because every virtualization level has a small performance impact, like every virtualization. If you really want to have the best performance, you run maybe your large database server in a Linux LPAR. If you want to have a large amount of virtual machines for a development environment, you run it under CVM or under KVM. So really have the benefit is also you have a memory-to-memory data connection called hypersocket between these virtual machines, which is very fast, not only fast, but also secure, because you do not need a network switch with cabling where someone can go there, touch there, and get connected.
Yeah, not outside of the machine. Yeah. Not outside of the machine.
Yes.
That's
okay. I think this is now your.
Okay. Yeah, go ahead. No.
Oh yeah, no, it's not. Okay, this is actually old data, but what it really shows, this is a chart we use to show that we do Linux since a long time, since 15 years, and since then, the installed capacity, IFL mainframe capacity used by customers is increasing steadily. Right? You see more and more compute power on the mainframe is used from Linux. So about 48% of all C systems enterprise is a big customer, are using Linux on their mainframe. And back to the question, either completely just only Linux or in together with CUS. 93 of our top 100 customers are using it. So this is a sign also that, and we see that customers who run CUS, our traditional operating systems, when they run Linux in parallel, they also grow their CUS footprint. Right? So it also helps the traditional business very well for IBM to grow, because it makes sense. But as I said before, you have your system of record in your database in CUS, and you're now able to plug new technologies, being some mobile stuff, being some data analytics, web serving, backup and restore data in front of your CUS in a Linux LPAR or several Linux LPARs. Right? So it's well preserved from our customers, and Marcus now has some success stories.
Some success stories. So another word on that slide. So the purpose of the slide and of the sessions is to make people aware it's a platform which has been out there in the market for a long time. And there are customers worldwide. You probably don't know that they're using a mainframe, but they are using a mainframe, and their workloads are growing. Plus, Linux helps to bring in new applications and new workloads on these systems. So there had been, I don't know how many times, suggestions or views of analysts and other people in the market that the mainframe is going out of business, it will be replaced by other solutions. It's still there, right? Since 50, 52, 55 years, meanwhile. 64 was the first one, yeah. So these numbers should underline that, that there is still a community out there of customers which are using these systems, and it's a viable community, and they're growing, okay? So here are some customer examples, and the question typically is, are there, what got them started, what they are doing in between, how long they are on the platform, and are there recent new things they do with the platform. So Dundee City Council is a fairly old reference now, but it's a very good example where a customer had a specific need. They were challenged to bring up new services and had a more or less outdated data center with multiple different servers in a very small space. And they calculated different options. They looked at blade servers running with VMware, but on the other side there, one of the representatives, and in this case it was an IBM representative, said, well, if you want to do virtualization and you want to run a database, feeding that applications you run on those systems, mainly web interface and a database behind it, that could also be very efficiently done on that platform. And then they went through the cost analysis, and they figured out for their workloads they had a very, very small requirement, but it was serving well the purpose to consolidate everything into a box and thus more or less get rid of 80% of the old hardware they had in their computers. And it was a room which was not much bigger than that. Before they started, it was kind of crammed with old systems. It looked like, how do you call these this used parts shops, kind of a computer museum. They were capable to consolidate the workloads to one machine, and they had one machine. And then they also had the need for disaster recovery, so they built up a second place and now have a failover strategy. If you go to the website of Dundee's city-facing web pages, where you can also go out to get your driver license and things being done. So they have web applications running up there. That's run by a mainframe, right? It's a very small customer, and they're very happy. It's very reliable, and they could save a lot on the software licensing part, and that kind of refinanced the hardware part in that case. So it balanced out very well for them. ICU IT Service is a very recent customer. They run different types of services on the platform. They're looking into LinuxONE. They have traditional workloads they want to drive, but they also want to get into a more DevOps-oriented work environment. They have ZVM running now, but they're also looking at KVM on the mainframe. IBM has made a product based on the open source hypervisor. We are supporting it since SUSE Linux Enterprise version 12 SP1. So they're running both on that platform. ZVM currently for production, KVM now to explore new things, and they were very happy with the platform because they're very, let's say, oh sorry, I need to go back. The servers are not much loaded, so they can really cram lots of virtual instances in that system, while they still have the possibility to extend, and if they need more capacity, they are very flexible with that. This is also a reference which is a customer for years. This is the Bank of Tokyo Mitsubishi. We have customer reference customers, the two biggest banks actually in Japan. They are using their parts of their banking system and online transaction or web-facing infrastructure for online banking based on that platform. This one is really huge. So they run multiple mainframes in the background to drive their transactions. We had an internal presentation by them, and they're saying, well, in the past 6 months, the average on onboarding new customers have been around 60,000 per month. So that's if you think that those customers will check their online account, they will do transaction, that's a really huge amount of workload which is driving the system, and you need to be prepared for that growth. And they are very happy to have that platform available from the hardware side, its scalability, and from the application development side to run that on SUSE. And
I think this is also a good example because SUSE and IBM together, customer had a special requirement in regards of storage high availability, and which was not included in open source technology or neither in SLES. So we worked together as IBM and SUSE and provided specific code and special service for them, which benefited the customer and also us.
It was one of the storage side. The application do not tolerate a timeout or an I/O request pending for 10 to 15 seconds. So we needed to develop a system which can actually buffer that and with redundancy. And then when the systems comes back online, does the mirroring in the background. So they need a very reliable, very scalable version and a support for very long life cycles of their application, because the qualification process they're going through due to compliance is very long. So what they basically do, they make a project, they make it work, and then they maintain it for a long time, and then they focus on the next one to be launched in 5 to 7 years, and then it's run. Very long life cycle and planning cycles there.
And for this you need a partner who can provide this long-term support. Yeah. Which IBM is used to it, but in the Linux space, SUSE is the key partner who also provides this. Right.
Okay. This reference is one we had people also presenting 2 years ago in the SUSECON 2014. This is an interesting story because that company, it's one of the banks in Brazil, and they were starting as a very small band, but they had a very rapid growth, more than 30% regarding customers and revenue. and they needed an infrastructure which can grow. They were lucky at a certain point in time to hire a CIO which was familiar with mainframes and also with Linux on the mainframe. And what they did in the first place, they dealt with the daily issues, but they developed a plan how they want to migrate to an infrastructure. They developed the people, they did education, they hired new people, and then they executed on the plan. It took them 2 or 3 years. But now they have a very good workforce of very young people managing those systems, and they are growing year by year, but now with confidence and relief, because the scalability and the consolidated platform of the mainframe is easy to manage for them, and it's providing also cost savings. They did a fairly intense analysis on the TCO, which they presented 2 years ago. So the presentation is still available. If you're interested in that case, you can pick it up and walk through it, and I can provide more.
I think they opened a branch office every day one in Brazil, and each of these offices, finance office, needed some IT infrastructure, and they could make the math. Okay, if we go on with our existing environment, it's uncontrollable, whatever, in the next 6 months. So they had to shift, and now they deploy the IT infrastructure for each branch office in a virtual environment within minutes. Right, so it's much easier, and they can plan ahead very easily.
Okay, so these slides are about the journey we had together until this point. We're standing here.
Yes, as you can see, we talking back and forth. So I know Markus since a long time, and we really have a good relationship, not only between Markus and me, but between IBM and SUSE. And actually, the first SUSE Linux Enterprise server was SUSE Linux Enterprise product was on the mainframe, not on x86 on Power. It was on the mainframe, and it was mainly driven by customer demand to provide an open source distribution with enterprise qualities, right? So, and then it's now available also for Power and for x86. We have other distribution partners as well on the platform. We not talk about this today, but you also see this is the MIPS growth I showed before. IBM and SUSE are constantly providing new updates and new technology. So we have Oracle on the platform. We have the majority of our IBM product on the platform. A lot of partners porting their products on the platform. We have even a program which supports partners and porting their products on our platform. So it's really a long-term journey. We do this since a long time and been very successfully. This talk, you can read this, but it's all good stuff. Yeah. So I think
this is not supposed to be read, but to
show. Yes, exactly. We do this more than 16 years. And as I said, right from the beginning, SUSE was one of the key partners. So the the first supporter of KVM and many more milestones.
Yeah, so when you look up the journey, and you've seen the slide before, how the MIPS in the market actually grew, you have early adopters when you do something new, right? And there was would not say resistant, but people were challenging the fact that Linux would be capable to run on a mainframe. So we had specific people trying it out, and then I found it's there, it's Linux, it's running stable, so can I do something useful with it? And I tried to adopt it. And while they were doing something useful, they figured out, here and there are some performance problems, also compared to other platforms. And that's what also triggered then development on the IBM side, on the hardware side, but also on the ZVM side. There were also different packaging options regarding ZVM. There was once a virtual integrated facility, which was basically a ZVM system living in memory, but that was only available for a short time. So we learned while we're going, and these steps actually show certain phases. Early adoption from people who were very enthusiastic. Then we had one of our first big deals from a provider from Sweden, Telia at that time. It might ring a bell, you might know it. Then, due to the virtualization capabilities, more and more workloads got put on the system, but then power or the processing capacity was a bottleneck. The I/O was a bottleneck. It was very good suited and optimized for ZOS. It was still a very great transaction system, but people putting their workloads on it, which the hardware was not designed for. And around 2005, when virtualization also emerged and took off on the x86 platform, IBM did a major investment to speed up the processing cycles, to extend the I/O bus and bandwidth to adopt newer technologies. And at that time, we have seen a massive growth in deployments because the numbers were just in favor for the mainframe. Still, people had to fight, do the business case, do the calculations, which is always recommended to compare. But that's where we've seen a very tremendous growth. And when the first use cases coming from deployment later, how do I secure the installation with high availability and disaster recovery, and that moves on until now.
Yeah, the story also was, before Linux, you could not compare the performance from a mainframe with something else, right? You just could not run a spec benchmark or whatever. IBM could always claim, oh, this is a fast system, but you could not run really a comparison. With Linux, you could. So people did, and seen, okay, this big machine is not really much faster than a big Intel system. And that really triggered also the hardware development he mentioned to really favor more these open source workloads. And I think with C10, this was really the big step, which was the first system which was developed in favor of Linux also, right? And today, Linux is one of the key, or Linux workload is one of the key drivers also for new hardware development. What I showed before, more memory, more compute power, stuff like that. Today, IBM is not talking about it much, but the majority of the email systems and a lot of the web stuff internally of IBM is a 400,000 people company is running on Linux on C.
Who knows about Project Green? Heard somewhere? The IBMs are excluded. It was around 2010, IBM got through the internal exercise to consolidate their data centers and their workload. So they did an inventory basically, and then they condensed those workloads to Z systems, power systems, and x86 systems. And that was a massive change and also a huge savings for IBM internally. Product portfolio. Oops. Yeah.
Yeah, can I do it? Okay.
Clicker.
Don't give me the microphone.
Yeah.
So I think I talked about this already. Our hypervisors, virtualization, we on a hardware level, which is with Prism. We have a new one, Dynamic Partition Manager, which is more focused on new customers, not familiar with mainframe terms like what is ECKD, what is a device, a channel, a device number, and the difference between a channel and a device number. We have KVM, we talked about that, and also CVM is our long-standing premium hypervisor. So you have full virtualization stack starting from the hardware up to level 2. Want to say something?
Yeah, this is also something where IBM goes into the direction to enable other people to actually communicate and do something on that system. So if I talk to the Z system guys who are familiar with Prism, logical LPARS, IOCDS, DESTIs, that will ring a bell. If I talk to those who don't know and say, well, this is a virtualized storage resource, this is a virtualized network, this is a virtualized channel or adapter, you can create a VLAN in that box, and I give you a web-based interface to do so, you know all about memory, you know processors you need, sometimes many for multi-threaded applications, maybe weighted processors or full-speed processors, dedicated ones where you want to achieve. This sounds familiar, right? And this is the translation, basically. So IBM is putting new solutions in that place so that people familiar with the concepts can actually interact and work with the mainframe to have a very scalable server.
It's funny, he makes advertisement for IBM, yeah. I'm for SUSE, but he's right. So this is really the beginning of the journey. So we do it from bottom to top. So we started really to make the creation of a logical partition easier, not talking about mainframe terms. The next step really obviously is, and we started doing this between IBM and SUSE, the operating system, because it doesn't help if you then install your SUSE and it's asking you again, what is your read, write, and data channel for your OSA adapter, right? So we need to make this modernization through the complete stack. Okay, CVM, just this is in the market since a long time. We will GA a new version this Friday, version 6.4. And what you see here also is, I mean, remember, CVM was developed 45 years ago, and nobody thought about these large requirements they have today. Right? So it is really a challenge for the team to put more and more, keep pace with CPU and memory scalability. So therefore you see we did enhancements. First of all, we clustered it in 6.2, 6.3. We had 1 terabyte per CVM. And now with 6.4, we enhanced this to 2 terabyte. So, and I guess going forward, we need to do more enhancements in this direction because customers want to use more and more virtual machines, but more and more virtual machines also in one CVM system. So it's also a challenge, to be honest, to make these enhancements to a hypervisor which is 45 years old. This is also a reason we brought KVM on the platform, because for KVM, running it under 2 terabyte, 10 terabyte, whatever, is no problem. It's open source technology. It is designed in that way, right? Yeah, that's the reason. So KVM for IBM C systems. We have here interesting. IBM is working differently here. So we did put out a statement of direction in January 2015. In August, we announced and made it available in September. And since then, we deliver updates every 6 months. So it's not like every 2 years you will see a new release. Every 6 months you see updates with bug fixes and new functionality. So it's kind of a different, I will not call it agile, but more delivering more functionality quicker to our customers with KVM. You put this chart in?
Yeah. So that picks up what we have seen in the charts before. So we're trying to, at the points where functionality in the Linux system can actually benefit from the innovations underneath it. It could be in the hypervisor area, ZVM or KVM, or on the hardware side. We put those things into the refreshes we do. So, for example, KVM can run on a Z13 system. Z13 system, the processor had support for SMT and SIMD instructions. So SMT is multi-threading, basically multiple threads too at that point in time. SIMD is single instruction, multiple data, what you usually know from multimedia, but it's very powerful also with regards to analytic functions. You need to have, from the processor through the different layer of virtualization up to the operating system, all these layers need to be able to deal with that changed instruction set, right? And at the first release from KVM, this one were not available. So now with the upcoming release and with the new service pack, we are able to exploit this. We also able to exploit it on the SP2 side. We'll have a slide later on that one. Very strong focus also on that machine has been due to its deployment in a different organization, governmental, insurances, banks, is security. They try to put in everything they could do with regarding cryptographic functions and support so that data is being protected. Either data at rest on the storage parts or in flight, meaning being delivered through via the network or not. So there are specific hardware facilities which allow to offload the compute-intense cryptographic functions and get the cryptographic content back. The SI instruction, start interpretive execution, is the capability built in the processor which allows virtualization. LPAR is actually a first level of virtualization where when you create a partition you can start an operating system and bring it down independently from the others running in parallel. When you can start VM in such an LPAR and you can bring guest up and down without impacting the other ones in that LPAR. Exposing the SI capabilities gives capability now to KVM that you can run KVM as a guest in KVM. That allows mainly for training purposes or for abstraction of workloads that you can use the tools you are familiar with to build a cloud in a cloud, for example. It will suffer a bit, the operating systems will suffer a bit from the lacking hardware support after that second level. But it's still very useful in training environments, in proof of concepts, and in testing. Okay.
Let me say one word for what's really important for our existing customers also, that we in IBM do investment in both, right? KVM does not mean we do not new releases for CVM, right? So we brought KVM. We bring now a new release 6.4, and we're also working on another release. So that also CVM customers who put a lot of investment in this area will still get enhancements in new releases.
So as another example with ZVM 6.4 support, we are testing in parallel while IBM is getting this out of the door. We're participating in the so-called beta program, basically, that the new versions of our product can really support also these 2 terabyte large instances. SSI integration is single system image. That's you can cluster VM systems to form one system, and then you would be able to move instances around in that cluster. That's good for when you have to do some hardware maintenance on one node, or you want to refresh some code on the underlying system. Offload. Sorry? Yeah. Offload is also a topic very often. The underlying Z hardware very often has facilities to offload tasks from the main processor. So if you remember that square where there was just a number of processors, you need to take into account that when you have a machine with 20 or 50 processors which do the workload work, there are up to 600 processors do I/O, cryptographic support, and other types. So lots of the workload is offloaded so that the process can really focus on the tasks they can do. Okay. One other example is collaborative memory management. That's a facility in the system since a very long time. The idea is if you have a virtualized system, the hypervisor actually does not know what the Linux system is doing with the pages. So if a page, so this is used to avoid that the thrashing, so that pages which are just recently used by Linux get swapped out to disk from the ZVM point of view, so both systems can coordinate their activities among each other and allow for a more efficient use of the existing resources. Another one which is not available on other systems as far as I know is the discontinuous safe segment. Within ZVM you can specify like a shared memory area which is shareable across the different Linux systems, so you can exchange data very quickly while still have the isolation of a virtual machine. And those segments can also be used to place code in there. You can start a system from that. It is a memory, it is addressable as a device, so it can boot up from a memory segment. Guess what? It's very fast. You don't have to do any I/O. It's already in memory. So startup times can be very quickly. And if you have to spawn up server farms, which are just for scale out, then you can use that one segment to start all these guests. So there are a bunch of technologies, and that's one example where the mainframe technology can actually allow for different use cases that are not available on other platforms. SUSE Manager, part of our product portfolio when you manage lots of virtual machines, you want to keep track of are they updated, security applied. So SUSE Manager is working well on that platform too, as it is on the other ones. Increase uptime. So live patching is available as a technology. So we have customers, thousands of images. That might be a use case, but you don't want to recycle those images every time you do a kernel update. So if you have interest, let us know. Technology outlook. And I think
yeah, very quickly. So because I want to also leave some time for questions. So IBM is in the years before really was mainly focused on providing technologies, and sometimes developers thought, oh, this is a good idea, let's do this. So we're much more focused now on what the customer wants, right? We're going really having a conversation with customers, with design thinking, offering management. So you will see enhancements, obviously also in the hardware. So we're still investing also a lot in new machines and new processors. But you'll see also more enhancements in the operating system area and also what software is supported. Right? We're engaging more ISVs to come on the platform, more open source product, and so on. This is no surprise. Performance gains will not reached anymore just by getting down with the structure size of the processor. This is an industry standard. So going from 32 to 22 nanometers will only bring a very little bit of performance. So really, you have to do some innovation to gain these performance improvements. Intel is doing the same thing, right? All processor vendors have the same work with the same physics, right? And therefore, IBM is investing still in new technologies for processor design. Right? I have really no clue about what all these things mean. Right? It's really highly, he does. But they invest a lot of money, 3 billion, also into new processors. There will be new machines coming, even though we don't have our own manufacturing anymore. We're working with global foundries. The development and the design of the processors are done in IBM, and IBM will further invest in this also for C systems, right? And as I said, where comes these optimizations from? First of all, some accelerators. So we will see some accelerator cards, adapters inside of the machine. We also use more industry standard attachments like PCIe adapters, like maybe think about some new flash technologies, NVMe, stuff like that. So we're using more and more of these technologies. And this all together will also bring performance improvements and more functionalities to our customers and using a lot of open source technology. Okay.
Just a few words. I think we will make that the final slide to open up for questions. So we've covered a lot of a big range, going from hardware, going through the virtualization technologies, going through use cases. So what we try to achieve with SUSE Linux on the mainframe is support both targets, the traditional Z systems platforms where workloads as databases and web application services are run to. We have a huge amount of ISVs who have certified their software running on SUSE Linux for the version being supported. So that's continuing. GreenStack is a summary of what we actually can put together as a portfolio, as an ecosystem, to provide similar services on these systems, not only the operating system, but also the system management parts, new technologies, new code that would help you to explore new capabilities with open source software. So we have introduced SUSE Package Hub as a means to that. Slash, as the operating system has a selected amount of packages, we provide L3 support for those packages down to the code level fixing. SUSE Package Hub will give the possibility to use precompiled packages in addition to that, but without that in-depth support and service level agreements. We pick up the innovations which are coming on the software side and the hardware side. We have a very strong focus on the secure and optimized environment. We are doing we're putting major efforts in having security certifications which are required by governmental or banking organizations, so that the whole system can be really used with confidence by these customers. Open Mainframe Project is an initiative of customers putting together to articulate the focus on the new technologies where they are, so that they can prioritize. And I already mentioned SUSE Package Hub. So that's basically the idea. We have a very viable platform in the market. Let me see if this is the. I think that's a good summary slide. This was GreenStack. It's really slow in the transitions. Sorry.
Yeah, das
dauert so long.
PDF Fullscreen.
Okay, so we have a viable platform in the market. We keep on keeping track with the innovations we have, so that can be used for solutions and to build up your IT infrastructure based on a mainframe and SUSE Linux.
Yeah, and so he flipped over a lot of charts. I think the charts are available for download.
Yeah.
Two things I want to mention there. There is the community cloud where you can get access to a mainframe to either play around with it or do some development on it for a limited amount of time. See us at our booth, because there's also some instructions how to do this. There's also the class model, and also about education, getting new skills on the mainframe. There's a lot of initiatives going on from IBM as well, and I think we put some URLs in there as well. With that, I think we have a little bit of time for questions, so we ran over, but are there any questions? There's a question.
So, short question on ISO. So KVM, is it the same layer as CVM? Can you just do KVM and an L5?
Yes.
You have to have the SUSE as a host on KVM.
That was 3 questions already, but that's okay. I will repeat the question. So what about KVM? Is KVM a small layer that you can run on Alpa? KVM is kernel virtual machine, so you will bring up a Linux system, and KVM works the same as it does on the other platforms. It will create a virtualized context where you can run a different operating system in it. It uses the same underlying technologies. In fact, there are comparative slides done by the engineering team and the developers who actually compare the different technologies, right? So from a technology perspective, these are 2 different environments. ZVM is, let's say, a virtualization environment, comes with its own nucleus and its own structure to manage the resources it's administering. With KVM, you bring up a Linux system, you have a Linux host then, and then you will have Linux guest systems. But they all run on the LPAR level, so they need an LPAR to run on their own.
So you have to have SLAS in an LPAR to do KVM besides SLAS.
You don't have to have SLAS. The IBM product brings its own operating environment, and in that it can create virtual machines which could be of different type.
And you can run it in parallel. One LPAR CVM, one LPAR KVM, and another LPAR something else. So you can run it in parallel.
Yeah, you need the LPAR boundary to separate the ones. And then the second question.
That's a longer question. So how do you see the Z in today's cloud infrastructure?
How do we see Z in the cloud infrastructure?
Specifically compared to Linux and Cloud Foundry,
Mm-hmm.
does it make sense to install Cloud Foundry on Z, or it's not the right type of workload for Z?
You? All right.
So as this stuff is still evolving, the cloud stuff, right? We try to enable several of these items. So we work with SUSE together with SUSE OpenStack Cloud. I think it's supported now with CVM with version 7, and there will be enhancements like that. So we keep that open for our distribution partners to enable cloud technology as well. Cloud Foundry, we're currently also looking into together with SUSE if we enable this. And particular to Bluemix, it's not available yet, but we're also talking IBM internally about enabling it so that it can be used. We're not there yet.
Yeah, but so is it the right type of workload, like real lightweight microservices, Node.js? Is that the right workload for Z?
So
better be reserved for something.
The answer is yes. So it's the machine offers the capabilities from its technical foundry, but you need the software ecosystem on top of it to make those workloads realized. I can point you to some proof of concepts, demos IBM has preparing in that area to show what the machine is capable to do.
And also customer demanding exactly that. So customers want to run these heavy workloads and also these small containerized workloads.
At the same time.
Yes.
Yeah. Okay.
Okay.
So thank you very much.